Hello guys, in this video I'm going to show you another method for solving trigonometric integrals. So first off, if you see sine of x to the power of whatever and you see it being multiplied by a cosx to a power of n being an odd number, then you want to use the identity cos squared x is equal to 1 minus sine squared x. And if you see tan to the power to an even power, tan x to an even power, and you see secant x to an odd power, then you want to solve that trigonometric integral using by parts integration. So let's see, let's look at an example. So secant cubed here. Let me get rid of that. So secant cubed, you got odd and tan is even, because tan is to the power of 0, but 0 is technically an even or an odd number. So we can use it. So this will be secant squared x times secant, and I'll show you why I do this. So we need to break it by parts, right? So let's have two parts, right? We know the integral of secant squared is tan, so let's make that the secant squared one. So v would just be the integral of that, so that's just going to be tan x. We have u is equal to secant x, so du is going to be secant x tan x dx. So now let's do our thing. So we got u times v, which is what? It's going to be secant x tan x, right? Minus the integral of v, which is going to be tan x, times du. So secant x times tan x dx. Okay, so this part is good. Now we're left with this integral. So how do we solve the integral of tan squared x secant x, right? Well, there are two things you can do, okay? So you could technically apply this rule right here. We have tan to an even power and you have secant to an odd power. So you could do that by parts again, or you could just do this trick. So we know that sine squared x plus cos squared x is equal to 1. Let's isolate for tan squared. So we're going to get secant squared x is equal to, so that's dividing by cos, is equal to 1. And this is going to be equal to tan squared x. All right, so let's plug that in. I'm going to erase this so it's less messy. So it was secant squared x minus 1. I forgot the dx, sorry guys. Times secant x dx, right? So now this is similar to an integral we've done before. We have secant cubed x, right? Dx minus the integral of secant x, right? So well, secant cubed is the question. So let's rewrite it. So secant cubed x dx is equal to secant x tan x minus the integral of that, which is equal to this, minus secant cubed x dx minus secant x. All right, so we can isolate for secant cubed. So the integral of secant cubed x dx is going to equal to secant x tan x minus the integral of secant x over 2, right? Moving this over and then dividing out. So moving this over and then dividing out. So now what is the integral of secant x dx? Well, this is actually an identity. You can do this. And maybe I'll show in a later video, but this is an identity you should memorize because it takes far too much time to do that on a test. It's a pretty common integral you're going to run across, so there's no point doing it every single time. It's equal to ln of tan of x plus secant of x. It's equal to that. So let's rewrite it. Secant x tan x minus ln tan x plus secant x over 2, right? Okay, next one. So we have sine to the 4 and cos to the 3. So if sine is to the 4, it's whatever, okay, and we have the other part of the case, which is n is equal to odd, so the cos is odd, so we're good, right? And what identity do we use? We substitute cos squared for 1 minus sine squared. Okay, we can do that. All right. Okay. To be equal, sine 4x times, sorry, was that 1 plus? Sorry, I don't, 1 minus, oops. 1 minus sine squared x times cos x dx. Now we just use u substitution as we did in the part 2. U is going to equal the sine x. Du is going to equal to cos x dx. Substitute this in. So you're going to have u to the 4 times 1 minus u squared. And cos x dx is gone, so just du. Now we got to integrate this. This is equal to u to the 4 minus u to the 6 du, which is equal to u to the 5 over 5 minus u to the 6, u to the 7 over 7 plus c. Forgot the plus c there, right? And then we're going to just substitute back. U was sine, so sine to the 5x over 5 minus sine to the x over 7 plus c. Let's double check. So we substituted in the identity 1 minus sine squared times cos times sine to the 4, right? That gives us u to the 4 times 1 minus u squared. The cos dx goes away. Multiply in. Yeah, that's the answer. Okay, second last one. We got sine cubed, cos cubed. Cos is odd, and sine could be whatever. So once again, let's do it. Sine cubed x times cos x times 1 minus sine squared x dx. U is equal to sine x. Du is equal to cos x dx. Alright, let's substitute that back in. So u is going to be u to the 3. Cos dx cancels out. 1 minus u to the 2. Du is going to be u to the 3 minus u to the 5. Du u to the 4 over 4 minus u to the 6 over 6 plus c. U is just sine. Sine to the 4x over 4 minus sine to the 6x over 6 plus c. Alright, next one. So actually look at this integral and look at the first integral. Look, this is the part of it that we were doing. We were doing secant, yeah, we were doing tan squared secant. Right there, you see it? Same one. So let's do it the other way now, right? So tan squared secant x, we have it where? We have it right here. Do by parts. Okay, let's do it by parts. V prime is tan squared x, v secant x, right? U secant x, du is secant x, tan x dx. uv is equal to what? uv is going to be secant x secant squared. Is that right? Seems like it. Secant squared minus secant x times secant secant tan x dx, right? So let's see here. we have secant squared, right? I'm just trying to make sure this is tan squared is equal to secant. Yeah, u is equal to secant. Du is going to be that. Okay, see, you could do it this way. Or again, you could do it my way, right? Which is, you just do, what was that again? It was secant minus secant squared x minus 1 times secant x dx. Right, you could do it this way. We already did it that way, right? You just break it up, you get secant cubed, and we have, actually this will be the easier way, right? Don't pick the hard way if you can do it the easy way. That's what I like to say. This is the hard way, right? So what you'd have to do here again, you'd get secant squared tan x, right? Which is another identity. It's another method of solving these trigonometric integrals, and I haven't showed you the rule for it yet, so I don't want to do it. I'll do that in the next video. But this way, again, you can break it up again. So secant cubed x dx minus the integral of secant x dx. And so secant cubed x is also a very popular integral. So what you just have to do, this would just be ln secant x plus tan x, and secant cubed is just this. So, sorry, it would be this. It would be that. But I'll show you how to do the hard way once I show you the rule for it. If you guys have any questions, please leave them in the comments. If not, have a great day.